let's talk a little bit about what this position along a common scale is all about. So there's a whole area of graphical perception. A lot of this was started by Cleveland. Cleveland ran a lot of laboratory experiments where he tried to understand what the eye could perceive most accurately. So I'd now like to tell you a bit about graphical perception. So the goal of any graph should be to convey some intended information in a way that your audience can understand quickly and unambiguously. So remember, Tufte said something about complex ideas communicated with clarity, precision, and efficiency. So there's really a process that's taking place. We have some idea that we want to communicate. And in order to communicate that, we want to support it with some data and some graphics, some evidence. And the way we're going to better communicate this idea is by first encoding it using graphical encryption devices, I'll call. So various ways of representing our data in a graphical way in order to communicate this idea. Now, once we've encrypted it into a graph, the audience is going to have to decode or decrypt what we put in there. So in order to communicate this efficiently, we need to make sure that the way it's encrypted into the graph is easily decoded by our audience. So Cleveland did a lot of experiments where he tried to understand what encryption devices for a kind of sounds like a fancy term, but which encryption devices are going to be most easily decoded. So the most easily decoded is going to be position along a common scale. So what we mean by that is, for example, what you have with a bar chart. So let's just flip ahead for a second. If you look at a bar chart, we have a common starting point, and then the position of the end of the bar is going to be an indication of the number. So that's what we mean by position along a common scale. Another encryption device is using length. So we can make the lengths of things proportional to the numbers we're trying to encrypt. This is the device that's used with a stacked bar chart as an example, where we have different lengths representing the numbers. We can also represent numbers as angles, so we can make the angle something proportional to the number we're trying to represent. Areas, we can make area proportional. We can use color intensity and volumes, but these are usually very difficult to decode accurately. I want to give 3 more words of advice in this lecture on perception. So first 2 are from Tufte. Eliminate unnecessary ink and eliminate chart junk. More on that in a minute. And then the third point is really one that Cleveland makes, which is proximity increases the accuracy of comparisons. So at this point, I'd like to give you a little exercise that illustrates how well we can decode things. So first off, I'm going to increase the scale a little bit, and I want you to look at this thing, pause the video, don't look at anything else at this point, and tell me what the story is. So pause the video, tell me what the story is. All right, welcome back. Here's the exact same data shown with a stacked bar chart, and I want to see if you can understand what the story is. What is the story being told? So we have these 10 values, labeled A through J, just as we had on the pie chart. So what's the story? Now, I'll show another representation of this on the next slide. Actually, I'm going to show you 2 more representations. which is first with a bar chart, then with a dot plot. So I think the story is very obvious when we look at the bar chart. So every other one is small, and then every other one is big. So A, C, E, and G are all small. B, D, F, and H are all big, and they're all kind of around 13, whereas this is around 7 or so. All right, so that is completely obvious, and I hope you'll agree that the bar chart makes that difference completely obvious. Now, if we go back to the pie chart, I'll bet that most of you did not see that story. Now that you know what the story is, that every other one is big, it doesn't leap out at you the way the bar chart, which leverages position along a common scale, it doesn't leap out that way. Perhaps some of you saw that story with the stacked bar chart, where having revealed the story, it's kind of obvious that every other slice is small, but it's a bit harder to see. It doesn't jump out at you the way it does with the bar chart. Now let's go back to one of Tufte's favorite lines, which is erase unnecessary ink. Tufte would argue that there's a whole lot of unnecessary ink on this chart. So where's the unnecessary ink? Well, bar charts really use 3 graphical encryption devices to encode the data. The 3 devices are first position along a common scale. So the end of the bar relative to this common scale is one way of representing the data. Second, the lengths of the bars are going to be proportional to the numbers. And third, the areas of the bars. Well, do we really need to show the numbers in 3 different ways? And the answer is no. So let's erase all the unnecessary ink, and that's what you get with a dot plot. The dot plot just shows where is the end of that bar relative to a common scale. The beauty of this is that we've just freed up all this space that we were using for the bars, and we can use that to show other things, as we'll see in a few minutes when we get to the next video. All right, so that's an example of erasing unnecessary ink to free up space to tell a richer story. So let's go back to the restaurant example, and there's a couple different ways of making bar charts if we want to leverage this. So we can either group by segment, or we can group by area to improve. Now, this brings up the last point on that slide, which is proximity increases the ability to compare. Okay, so if we use the bottom graph as an example, it's very easy to compare light users versus heavy users versus new users. Those comparisons, so how important are new items to heavy users versus light users? That comparison is very easy since it's proximate. It's a slightly more difficult to make that comparison up above. So how important are new items to heavy versus new? Well, I have to compare this bar to this bar. Now, this is not as difficult as a pie chart because notice everything starts at the same point. So it's pretty easy to make that comparison, but not as easy as it is down here. Now, the top graph is going to be better for comparing across area to improve within a segment, because these bars are approximate to each other. So when you're making graphs, you want to think about what comparisons do I want my audience to make, and then put those comparisons in close proximity, ideally using position along a common scale. Let's now talk about Tufte's point on chart junk. So what is chart junk? So chart junk is stuff that you put on a graph that's really not necessary. Here's another version. I threw this into the spreadsheet program Numbers, and I asked for a 3D bar chart, and this was the default that they gave me. And I hope you'll agree with me that this is absolutely hideous. So yes, the 3D effects are really cool. Yes, the shadows back here are beyond cool. But in terms of telling the story, the 3D effects really obscure the story. So what exactly am I to compare? Do I look at this end of the service thing or this end in comparison with the back? I'm not quite sure about this. All these angles make it really difficult to perceive, what's with what. So I think this is an absolutely dreadful graph. Let me run you through what Tufte has to say about chart junk. So chart junk does not achieve the goals of its propagators. The overwhelming fact of data graphics is that they stand or fall on their content gracefully displayed. So graphics do not become attractive and interesting through the addition of ornamental hatching and the false perspective to a few bars. Chart junks can turn bores into disasters, but it can never rescue a thin data set. So Ed's rule is whenever you see a lot of chart junk, a lot of 3D effects and shadows and all this other crap, that probably means that there isn't much on this graph, and the creator of this chart is going to add all of these, all the chart junk in there to hide the fact that they don't have an interesting data set to begin with. All right, the best designs are intriguing and curiosity-provoking, drawing the viewer into the wonder of the data. So think about Napoleon's March on Moscow. Sometimes by narrative power, sometimes by detail, sometimes by elegant presentation of simple yet interesting data. But no information, no sense of discovery, no wonder, no substance is generated by chart junk. So the 3D bars are not going to give us any sense of wonder. Two more graphs. We could use a stack bar chart, which is going to rely on length to show this data set. I'm not sure this is as effective a design as perhaps the bar charts are. Again, we have to, the lengths comparisons are not horribly difficult to make since they're in close proximity here. We can definitely see that the red bar for new is much greater than for heavy. We can also see the black bar is bigger than heavy for new. So this is not a horrible design. Going back to the bar charts, I would say that there's way too much vertical in this. So it almost makes me a little dizzy with all these bars. So if we follow Tufte's principle of erase unnecessary ink, this is the result. So we can end up with a chart like this where we're going to encode segment membership using the plotting symbol. In this case, I'm going to use a mnemonic so that the audience does, we could have used stars, pluses, and circles, but then the viewer would have to remember, okay, what is a star? Star is heavy, circle is new, whatever. Whereas if I use N, H, and L, those are mnemonics, so H is going to be heavy, and people can remember that with more ease. Now you might ask, why do I use a little n versus a big N? The reason I'm going to use a little n is because of visual contrast. A big N looks a whole lot like a big H and requires a lot of processing to distinguish, whereas a little n and a big H are very different. Okay, so notice by erasing unnecessary ink, I free up all sorts of space, and I think this graph is quite good in that it facilitates both comparisons, the comparison within segment and the comparison across these different areas to improve.